Hello, my name is Beth Randolph. I'm the project manager with ES3 out of the Southeast Operations Office located in Warner Robins, Georgia, home of ES3's Brush Plating Research and Development Center of Excellence. I will be presenting our U.S. Navy Phase 2 SBIR effort related to SBIR topic AF-172002. Demonstration and validation of brush LHE alkaline zinc nickel as a brush cadmium alternative. ES3 is a women-owned small business founded in 2000. We are a high-end engineering firm that does engineering contracting work for the DoD, as well as commercial aviation industry. Within our office, we have just about every major engineering discipline represented, as well as chemists, biologists, logisticians, A and P and IA licensed mechanics, sheet metal mechanics, machinists, welders, surface finishers, etc. Although we are small in size, we are a recognized world leader in aircraft and landing gear expertise and an R&D powerhouse. The SBIR topic, AF-172002 effort, addresses the U.S. Navy's need to develop an improved brush zinc-nickel solution and process as a brush cadmium alternative. For those not familiar with brush plating, it is primarily utilized to repair areas that have been tank-plated, or for touch-up work from damage ensuring corrosion protection to the component. The primary objective of this effort is to eliminate brush cadmium plating due to its hazardous waste and health hazards to personnel, while simultaneously improving the process. One of the improvements of this solution is the increased corrosion protection it offers to aircraft components. NAVAIR's primary goal for this effort is to receive the required technical and demonstration data necessary for NAVAIR certification and general authorization. This will enable the adoption of this solution and process at Fleet Readiness Center repair depots and active duty field locations. This slide lists a few of the operational uses and improvements that this brush plating solution and process addresses. For example, replacement of brush cadmium, corrosion protection, etc. Additionally, the process is environmentally friendly. In addition, under another effort related to this SBIR topic, ES3 is also conducting a tri-service effort with the Navy, Air Force, and Army to further implement the brush zinc nickel plating process. A demonstration of the advanced process equipment and plating procedures is scheduled to be performed at Fleet Readiness Center Southeast in Jacksonville, Florida in 2024, and interested parties are welcome to contact ES3 for further details if you are interested in attending. As we continue to see brush plating applications and usage grow within the DoD and commercial aviation sectors, we are seeing increased usage of cadmium. It's also important to note that current conversion coatings for brush cadmium contain hexavalent chromium. Due to the carcinogenic nature of cadmium and hexavalent chromium, this poses environmental and health risks. By eliminating and replacing cadmium, this process and solution improves the ESOH conditions for technicians and shop personnel. Since the new brush zinc-nickel process uses trivalent chromium for the conversion coating, which is much more environmentally and health-friendly, brush zinc-nickel and trivalent chromium waste products are more economical to dispose of since they are more environmentally friendly. As a side note, a benefit of this solution is that it is available and manufactured in the U.S., whereas leading competitors are sourced from foreign sources, making it more readily accessible for U.S. supply chain. And last, but certainly not least, a major bonus benefit is that the new brush zinc-nickel plating process also has shown superior performance in required testing criteria, such as corrosion resistance, abrasion resistance, and reduced toxicity, when compared to using cadmium. This is particularly important as users are seeking to ensure the coating meets all structural and performance requirements for the brush plating application and increasing the service life of the parts and systems they are applied. The status of the solution and process is a TRL 5. During this effort, there will be a down selection of the brush zinc-nickel solution and an optimization of the solution and process for the option period of this phase. This table shows the milestone tasks, risk levels, current and ending TRLs, and estimated completion dates of each milestone task item. A few of the main advantages of the brush zinc-nickel solution and process are as follows. The process is improved by having complex geometries and inside diameter, outside diameter plating capability. Additionally, plating by amperage instead of voltage allows for better control for the plating. Deposit and thickness. Additional anodes will be designed for aircraft components for complex geometries. The equipment will be evaluated early on, so any enhancements or improvements can be addressed and incorporated into the equipment and process. The new brush zinc-nickel solution performs better than any currently on the market and is manufactured in the United States. Our strategy for transition and implementation to the fleet is comprised of the following. ES3 has provided input to the customer for development of their technology transition agreement and statement of work. Additional testing may be identified as a need based on the various requirements across the Fleet Readiness Center sites and program offices. If this testing is required, additional funding will be needed. ES3 has worked with our Fleet Readiness Center Southeast customer to develop an integrated master schedule that shows a 3-year project, 18 months in each base and option period. This integrated master schedule documents the schedule and tasks required to meet the requirements identified by the customer, which includes coordination with Pax River and other fleet readiness centers. Once completed, the Navy plans to begin the process of integrating the use of the technology after receiving an eventual letter of authorization. Initially, the target market for this technology will be NAVAIR, NAVC, and other FRCs and depots that require brush plating touch-ups and repairs. ES3 would like to meet with representatives to better understand their specific needs. As far as commercial applications, ES3 is interested in any customer who has a serious interest in the solution and technology, such as industry collaboration and original equipment manufacturers. The Air Force and Army are obvious potential market candidates due to the current ES3 tri-service effort, and are in routine meetings for technology updates as the effort proceeds. ES3 has on contract a tri-service effort with the Air Force, Navy, and Army for the demonstration and validation of a dripless brush system. It is currently in the 2nd year, and 2 demonstrations have already occurred at ES3 GTOC and Robins Air Force Base. Eventually, ES3 plans to use the dripless system with the solution and process that is being developed under this contract. Moving forward, ES3 will continue to help build these capabilities within the DoD. This begins with the implementation of the process and solution within the Navy after receiving a letter of authorization. Obviously, we are starting with DoD customers for initial implementation of this technology. But in addition to the DoD, we know this technology is applicable to commercial aircraft, ship, and automotive sectors as well. We will look at engaging these customers in the near future. Additionally, as mentioned on the last slide, ES3 is working with the National Defense Center for Energy and Environment on a dripless tooling system that is a tri-service effort. The demonstration and validation at Fleet Readiness Center Southeast is planned to occur in 2024. In the future, ES3 plans to join this current solution and process with the dripless tool system. Here are some of the key performers on our ES3 Brush Zinc Nickel team. You can reach any of us if you have more questions or if you have potential brush plating needs. We thank you for your time and interest.